Today we are demonstrating the new updated lime requirement calculator for the WSU Wheat and Small Grains website. I'm Carol McFarland with the PNW Farmers Network and Washington State University, here with co-authors.
I'm Rachel Weemy, Regional Extension Agronomist based in Walla Walla County.
I am João Antonangelo. I'm a soil chemist based in Pullman.
Great. Thank you so much. And we'll go ahead and jump in. So here we have the Wheat and Small Grains website. You can find the new updated lime requirement calculator under Soil and Water Resources, the Soil Acidification tab, where we can scroll past quite a few other resources on soil acidification, to the lime requirement calculator. You will also find a fact sheet that will accompany the instructions on how to use this guide. In the meantime, please enjoy the tutorial. You may click here at the bottom, use the lime requirement calculator, and you will find the download on your computer. Then you can move into the introductory page on the first tab with a summary of how to use this calculator. You will see that there are several different options depending on the information you have and your region to determine your preferred lime requirement estimate. Again, please refer to supplementary materials in order to determine the right test for you and your soil. Let's start out by demonstrating the first tab, which is the Mehlich buffer test. To begin using the lime requirement estimate calculator with the Mehlich buffer test, you may use the buffer pH value reported from your soil test under the reported value column here in this yellow cell. Our example today, we will enter 5.5 for that value. The Mehlich buffer test calculates the soil acidity present in your soil and provides an estimate for the amount of calcium carbonate required to offset that acidity. This value is reported for a 0 to 6 inch soil sample at a 100% calcium carbonate equivalent. In this case, our soil sample depth was 4 inches, so we will use the adjacent table calculator to recalibrate our lime requirement estimate. Again, this number is in 100% calcium carbonate equivalent. If we would like to make this conversion for ag lime, we go over to the conversions tab where we may enter our calculated lime requirement estimate, 5,652, our soil sample depth of 4 inches, and our liming material calcium carbonate equivalent from our lime label. For our example today, we will use 95%, and this provides the value of pounds per acre of product needed to apply to the field. Moving on to the next tab, if you have the values for soil organic matter and exchangeable aluminum, or organic matter and soil pH, you can also approximate a lime requirement estimate in lieu of a buffer test. For our example today, we'll use 3.1% organic matter and 49 parts per million of KCl extractable aluminum. Our sample depth is 6 inches, which is the default for the calculator, so our estimate remains the same. Alternatively, you can use organic matter with your soil pH, in this case, 5.02. Again, our sample depth is 6 inches. These values are correlated with lab incubations and do show some variability around their respective correlations. So you can see the variability in the estimates provided for the same soil, but that reflects a variability in the correlation to the lab experimental results.
If the best fit buffer test for your area soils are one of our other buffer tests listed here, such as the SMP or Woodruff buffer, we would navigate to these tabs at the bottom. So here on the SMP buffer, let's say our soil test returned a value of 5.6, and we want to set our target pH at 5.8, for example, we would get a lime requirement of 7,950 pounds. Once again, just noting here, we'll see on our SMP and our Woodruff buffers reminders about the ranges that are best fit for these buffer tests. So for the SMP, for example, our target pH will be for 5.6 and 6.4. So if we did want to get up to a 6.0, we would get a higher lime requirement for this sample depth of 6 inches. There is more information available about the ranges and the best fits for these SMP and Woodruff buffer tests in the accompanying publication that will be linked on the landing page of the calculator.
All right, João and Angelo here. Let's dive now in the final two tabs of our tool, base saturation and reserve acidity. You are going to use this if you either do not have a buffer pH, do not have any specific target pH in mind, or do not see any kind of organic matter or organic carbon reported in your soil test. So these tabs focus on improving base saturation or addressing reserve acidity. Okay, it's going to improve the soil pH because you're going to apply lime anyway, right? So for the base saturation right here, the goal is to increase the proportion of base cations to acidic cations. Okay, so you can start by entering the soil pH value. Let's see an acidic one, 4.5. Okay. Then you're going to have to input the concentrations of your basic cations, calcium, magnesium, potassium, and sodium. The concentrations should be nearly equivalent by 100 grams, which is the unit most used by labs. But if your lab reports concentrations in ppm, you can use the conversion on the right of the calculator, right? So let's give an example for you here. Let's say you have 1000 ppm of calcium, 300 ppm of magnesium, 200 ppm of potassium, and 23 ppm of sodium, okay? You can enter 0 for sodium if it's negligible or not reported, okay? So let's transfer those values here. 5, 2.5, 0.5, and 0.1. You have almost everything for the calculator to give you your lime requirement, okay? You need the target base saturation, how much base saturation you want to achieve. So we do not have a precise optimum base saturation yet, but 80% is a safe target, okay? So you can set this as a threshold. Okay, once you have entered this, the calculator will automatically provide a recommendation. In this case is 2004 pounds per acre. Okay. However, can you see that some of the cells, the yellow cells here, they are empty? Okay. You can enter values there if they are in your soil test report and if you prefer to use them. If not, they are calculated here on the right column and they are used to give you the LRE value properly. Okay. But let's pretend that you have those values in your soil test report. Let's say 5 for reserve acidity. Let's say your CC is actually 14 and your actual base saturation is 6.5. So it's going to change accordingly, right? Or you can remove them all if you prefer, okay? For the sum of base, regardless of what you're going to do here, it's not going to affect the lime requirement estimate. But you have to look at the calculated value. It has to match exactly with the value that you have in your soil test report, right? That way, it's gonna serve as validation proof for you to see that you are on the right track. So let's move to the reserve acidity now. Reserve acidity is basically the same thing, okay? I'm gonna keep some of the values here, the same example that I used before. for the base saturation. But now, you can choose between estimating the liner requirement to overcome aluminum toxicity or to neutralize the reserve acidity, right? So let's give an example here. So for aluminum, exchangeable aluminum EXC, it stands for exchangeable, okay? Extracted with potassium chloride. So it also requires you to put the unit as milligrams per 100 grams. So let's pretend your soil test report is giving you in ppm. Let's say it's 180 ppm. So that translates to 2. You're going to put number 2 here. And then it's going to give you directly how much lime you have to apply to overcome exchangeable aluminum. Okay, but we know that exchangeable aluminum is only part of the reserve acidity. Reserve acidity is exchangeable aluminum plus other acidic cations. So if you have that value, like let's say 3.5, it's going to give you the value of lime to overcome all the exchangeable acidity, right? Or if you delete and you rely on the calculated value that you have here for you, you just enter 0 and it's going to give you the value anyway, okay? So then you can decide you're going to overcome just aluminum toxicity or you're going to overcome all the exchangeable acidity. Just one thing that I would like to bring your attention is if your soil pH is lower than 5.4 and for some reason your exchangeable acidity reported is higher, is lower than the exchangeable aluminum, sorry, then you're going to use the exchangeable aluminum, okay? Sometimes, depending on the methods used by different labs, the exchangeable aluminum value might be higher than the reserve acidity, especially, again, when the pH is below 5.4. In such cases, it's better to focus and neutralize the aluminum specifically, okay? All right, and remember, the conversion tab is there at the end to help you if you need to adjust some values based on your conditions. Feel free to reach out with any questions that you have. Thank you so much for everything and help calculating.